So last time around, we went through with functions and we saw, that functions are just simply a relation between an output and an input. And we even discussed what inputs and outputs were. Furthermore, we went on with, your domain and range. All right. So now we're going to look into um, what you may call different types of functions. All right. So what you may say is that there are, in our last class, we saw that there were what is the relationship between relations and functions. All right. So we're going to continue with this today, and we're going to look into the different types of functions that exist. All right. Keeping this in mind, we're going to go into hmm, just give me a moment. We're also going to look into the different types of functions that there are. Let's look at them. So obviously, whenever we're talking about functions, we're going to be just concerned with three types. And those three types of functions are, one of them is your one-to-many function. But oh, sorry, one-to-one function first, and then we'll move on to one-to-many and stuff of that sort. So a one-to-one function is very simply what you may call it. It's by the name itself. It has one output to one input. All right. So a one-to-one function is best described as something which has one output to one input. All right. Usually, these type of functions are linear functions. We also call them linear functions because linear equations and any sort of linear relationship is going to have what? One output to one input. So one output to one input. Is this clear, person? And if I were to, you know, give an example, I can give any example of this. For example, f of x is equal to 2x plus 3. All right. Now, looking at this is a linear function. Why? Because whatever input, whatever value of x you're putting into the function, it is only going to give you one value of f of x or one output to it. All right. It is not going to give you multiple outputs. And we'll see what type of functions give multiple
Assalamu
outputs
alaikum.
as well. Wa alaikum assalam, Nofal. How are you?
I'm doing good.
All right. So, secondly, you have many to one function. Now, what are many to one functions? We'll see that as well. So, whenever we're concerned about many to one functions, we're going to be concerned with the fact that what you may say that for multiple inputs, one output. So, it's going to have multiple inputs to one output. And usually, These type of functions include nonlinear functions. Nonlinear functions include your quadratic function, it could be a cubic function, any nonlinear function. All right. So if there's a many to one function, then that means that there are, it's in the name itself, many to one. That means for many inputs, it leads to only one output. One to one means for one input, it leads to one output. So, for example, a many to one function could look like f of x is equal to, you know, 3x cubed plus 2x squared plus 7x plus 1, maybe. It could look like this. So, this is a quadratic, particularly speaking, nonlinear function. And lastly, we have some functions which are not really in your syllabus, but you should know them. They are your one-to-many function. So we'll understand what each and every single one of these mean. So one-to-many functions, it's in the name, one-to-many. This chuckles me up. So for a one-to-many function, we know by judging its name as well that for one input, you have one input to multiple outputs. And these are also non-linear functions, but usually these type of functions include, some rare and special functions. Like if I could give you a function, it's going to be like f of x is equal to plus minus under root x. This could be a many to one function. Why? Because for multiple outputs or for one input, you're getting more than one output. Why? How so? You're putting in one value of x, which is one input, but you're getting a plus minus value of x. Therefore, you're getting multiple outputs. All right, guys, is this clear? So
Yes.
one thing that, yes, all right, that's perfect. So one thing that we need to know is, and then there was one thing that we're going to know is that there's vertical line tests and there's horizontal line tests as well, but we're going to look into the vertical line test. The vertical line test is not part of your syllabus, but it's a bit interesting. So let's look into it. Your vertical line test determines whether your function is one to one or not. All right. So, for example, what you may call all vertical line functions are supposed to be what you may call. mm, it's supposed to determine whether your function exists as a function or not. Let's see now. So vertical line test to prove a function, because we said that every relation is a function. Every function is a relation, but then not every relation is a function. So to prove a function, we conduct something known as a vertical line test. What is that? Consider a graph on which there's, any function at all. Like, for example, there's a quadratic function. There's a quadratic function. What happens with it is that a vertical line test is conducted such that you draw a simple vertical line. It doesn't have to be anywhere at all. Like, it doesn't have to be anywhere specific. You draw a vertical line and if it intersects the graph at more than one point, it is not a function. So this is a function, this is perfectly all right. But for example, what would classify as not a function? Okay, let's say that this will not classify as a function, which I'm about to draw. Something like this. This will not classify as a function. Why? Because when I draw my vertical line, it intersects at two different positions. So this is not a function. Is this clear, boys?
Yes.
So this is just to, um, tell you that it is a function or it's not a function. All right. For example, another now you can say that graphs like these also pass the vertical line tests. The vertical line needs to intersect only once. Okay, this it needs to have only one intersect. And for another very common example of not a function is the circle equation. The circle equation is not a function. Why is it not a function? Let's see. Because your circle equation is like this. If it's the equation of a circle, obviously it's going to form a circle. So it's not going to pass the vertical line test. 2 points of intersection. Therefore, it is not a function. Whereas cubic graphs and your other graphs, these all pass the vertical line test. So that is why they are, your functions, your what you may call, they are classified as a function. They are just simply not linear or quadratic function or stuff of that. Your many to one functions and your other functions. So more or less every function which passes the vertical line test, regardless of whatever type it may be, is a function. Clear? Keeping this in mind, let's, you know, I have to work with Desmos. I like using it. Let's try to see. Just give me a moment. No, currently there's absolutely nothing to see. Why did I open up Desmos? But nonetheless, we're going to keep it here. Any questions from this, guys? Anything that you guys don't get?
No, Mr.
All right. And at the beginning, I said that inverse is only possible for one-to-one function. So that means the inverse is only possible for this guy. Why is that the case? We'll see. Because now we're going to have to calculate inverse. So next up is your how to calculate the inverse of function. So we've done this before multiple times. It was in IGCSEs as well. And this is a very easy concept. You just need 5 steps. But in order to find the inverse, I need an example to begin with. Yes, so any example I can begin with is fine. Hmm, 7 minus 4x. And I know for sure that this is a one-to-one function. Why do I know that for sure that it is a one-to-one function? Because if I put in one value of x, like if I put x is equal to 2, so it's going to be 4 times 2, and the answer is going to be minus 1. Now you can see that one value of x being put as 2 gave me one answer of f of x is equal to 1, minus 1. Therefore, I know that it's a linear function as well as the fact that it's a one-to-one function. And the domain is always provided to you that x is an element of all real numbers. And you need to find f inverse. How am I going to do that? Let's see. So first off, we're going to write this guy down. Now your first step is extremely important. You need to let f of x be equal to y. Okay. And we'll see how that happens. So now what's going to happen is that the function will look like y is equal to 7 minus 4x. Secondly, you have to make x the subject. And how you're going to do that is going to be critical as well. And now I'm going to make x the subject simply by taking it as y minus 7 is equal to, or you can, take it onto the other side. So I'll do this as y plus 4x is equal to 7, which can further be written as 4x is equal to 7 minus y. And lastly, you can have it as y is equal to, no, x is equal to 7 minus y over 4. Then the easy stuff begins. Now, usually my students say that, maybe I'm just making stuff up, but no, this is actually the way that you're supposed to do it. Let x be equal to f inverse of y. So now I'm just going to write it down as f inverse of y is equal to 7 minus y over 4. And then the final step comes as what you may call replace y with x. And how you're going to do that is pretty simple as well. And it's going to be all the y's will be replaced now. So it's going to be 7 minus x over 4. Is this clear, guys? Any issues with this, boys? Anything that you guys don't get?
Issues.
It's pretty straightforward. All right, write this down, guys. Let me know when you're done. Assalamualaikum Zara, how are you? Zara was here, but she left. All right. Any issues with this, guys? Nofal, is this clear?
Yes, sir.
Perfect. Now, all inverse questions are going to be solved like this, regardless of how they are. Just make sure to follow these, what you may call 4 5 steps that there are. All right. Try to make sure that you're following these steps, and then nothing will probably go wrong. So these 4 5 steps are increasingly important. All inverse questions solved the same way. Now we're going to, once we're done with inverse, we're now going to move on with domain and range. So whenever we're trying to calculate, we have seen domain and range above as well. We have an understanding of what they are. So now we're going to see them in detail. And they will never ask you, the examiner never really asks you to calculate the domain of the provided function. No. The domain is always going to be given to you. But obviously, the domain, there are certain, we'll do certain scenarios as well of, when the domain is given to you, when the domain is, given as a range and stuff of that sort. We'll cover all of those. But usually, what happens is that the domain is always given to you. He's always going to ask you the range. But one thing is for sure that he's always also going to, ask you the range of the inverse, because the inverse is the function which was already not given to you. So he will first ask you to find out the inverse and then find out its domain as well, because you're the one who's creating the function. Obviously, if you're supposed to create a function, you're supposed to give its domain with itself. It's kind of like a manual that comes with the product. Keeping this in mind, let's continue forward. So when we focus on domain and range, we're going to have a few types of domain and range. What is that? We're trying to cover all the types of questions that the examiners might ask. So first off, we have type 1. Type 1 is that it's a one-to-one function. This is a scenario that the examiner has given to you. It's a one-to-one function. And the domain is given to me. Is given. But there's a catch. The domain is given as a range. So this is type 1, and we'll be focusing on this type first. So what happens when you have a domain of one-to-one, and you're given a one-to-one function, and the domain is expressed as a range. Okay. And by no means am I talking about this range. This is a different range. I'm talking about ranges like, okay, let's do an example, then you guys will probably understand better. So, for example, there is an example that f of x is equal to, um, let's say that 2x plus 3. And the domain is given to you as minus 3 is less than equal to x, and x is less than equal to 2. Now, whenever some sort of x information is given to you, that means that obviously x is going to act as your domain. X is the input. So that means that the domain is provided to you. So one thing is for certain, that this is my domain. And this is what I was referencing as the domain given as a range. Not as in the domain and range, but the domain itself is given as a range of numbers from 3 to 2. So this is my domain and it's given as a number. Okay. What will you do? Simply, what I'm going to do is put extreme values, or actually, if you want to find the range of this, put extreme values of the domain into the function. So let's see. The domain is provided to you, and obviously it has extreme values. Extreme values are minus 3 and 2. That means that these are the last values. After these, you cannot use any other value. You can use it from in between them, but you can use these, but you cannot use any other value from the number line as your domain. So the first step is put extreme values of the domain into the function. Let's see how that works out for us. So what I'm going to do is I'm going to put f of x is equal to 2x plus 3. And I need to find f of minus 3 and f of 2. Putting my extreme values into my function, that is going to give me 2 times minus 3 plus 3. And f of minus 2 is going to be 2 times 2 plus 3. So f of minus 3 is going to be equal to minus 3. And f of 2 is going to be equal to plus 7. This is telling us what? This is telling us that when you put in the last or the limits or the boundaries of your domain into your function, it is going to give you values which are obviously going to determine the boundaries of your range as well. Because you cannot put anything smaller than this and you cannot put anything greater than this. So obviously, whatever value of range you're getting for this domain is going to be the least value of your range or one edge of your range. And whatever value of your range you're getting in for this maximum value of domain is going to be your maximum value of your range. All right. So your range is going to exist as a range as well. And how will that be? You're simply going to take this and put this as what you may call um, as your range. So your range is going to be f of x needs to be less than equal to 7 because it cannot be greater than 7. And it Apologies about that, guys. I got disconnected. Okay, let's continue. So, where were we? I was telling you that the range is going to be determined by putting in, if you are given a one-to-one function and the domain is also given as a range, then you're just going to put in the extreme values of the domain into the function, and in order to get to your range, which is going to be equal to, greater than equal to -3. All right. And this will be classified as your range. Is there anyone who does not get this? Let me know. All right. Hopefully this is clear. Just give me a moment. Let's try and test this theory out. So, for example, if I am given a question and let's just say that f of x is equal to, what was my equation, 2x plus 3, right? That was my equation. And my domain was given to me as x is, sorry, -3 is less than equal to x, it is less than, which is greater than equal to 2. That was my region. Now this is my domain. You guys can clearly see the blue region shaded is my domain. Now, if I look at into my extreme values, this guy, this is also my, extreme value of my domain. And it is also having a corresponding, what you may call, uh, value for, this is also my extreme value. These two are my extreme values of my domain. So my x, what is my domain? All the x value that I can choose, the blue area, this blue line from this to this is actually my domain. My domain is what? That from x is greater than -3 to x is equal to 2. This is my domain. All right. Hopefully this is clear. This is my domain. Now, what is my range going to be? If I put into my range, that is going to be f of x is less than equal to 7. Why is it not responding to me? Okay. And this is going to be that it is less than, no. Why is it not? Me only supports all double. Okay. They are only telling me that double inequalities will not be permitted. My bad. 7. So now this region, the middle part, you can clearly see from this extreme value to this extreme value, all the values that lie in between this are my range. All the y values on this, like from this, these are all my range values. These cannot be my range values because they exist outside of my domain. My domain is from this value, my extreme value, to this extreme value. And all the values that lie in the middle from this point to this point, they are my range. So if you guys can clearly see, my range is the darker region in the middle, and my domain is also there. Is this clear? My domain is the values on the graph, and my range is my domain is, sorry, the values on the x-axis from which point I can take what sort of inputs I can take, and my, what you may call, all these values which exist in between the domain, they are your range values. Is this clear, anyone? Anyone who has any issues with this, let me know.
No, sir, it's clear.
That is perfect. Why does it not allow me to write the inequality though? Oh, wow. It did. That is excellent. I can, so this is my range. You guys can clearly see all my y values. So my domain is what? The blue guy, from this value to this. You cannot, you have to stay in between. And between this, my graph is only giving me values till here, till -3. From -3 to 7, my graph is giving me a y value. So that means my range of values I can get are from -3 to -3 to 7, and the values I can use are from 2 to -3. Is this clear? Zara, is this clear?
Yes, sir.
No, feel any issues with this?
No, sir.
All right. Okay. Now, what happens is, now what we're going to do is that we're going to leave it till here for today. We're going to continue this in our next class. Our next class is going to be on Thursday. All right, no worries. We will continue on with further types and as well. My throat is aching a little. That is why I'm ending it over here. All right, so we'll just continue this in our next class. And as always, have a very nice week. Let me know if there's any questions. Keep smiling. Allah Hafiz.
Thank you.
Thank
Take
you,
Bye.
care.
Allah.